Hello. So we have an unloaded car battery that has a potential difference across its terminals of 12.7 volts. When briefly connected to an external load resistor of 1 ohm, the potential difference across the terminals is 11.5 volts. Determine the internal resistance of the battery. So first of all, let's define the terms we know and the terms we want to know. So we have epsilon, which is the unloaded potential difference, which is 12.7. I'm not going to write down units for now. Then we have capital R, which is the resistance of the external load resistor, and a lowercase r, which is what we're trying to find, which is the internal resistance of the battery. So what we can do here is first let's express this in, put lowercase r on one side of this equation, and that would actually become, I'm not going to show all the steps, but if you expand and distribute this I, then you can, I think it'll end up something like this. Yep, it would look like this, and this would be equal to epsilon over I minus R. Now we don't know what I is, unfortunately, but we can use V equals IR. And we're going to apply this for the external load resistor. Okay, so, well, we know that I is equal to V over R. So we know that our R over V is equal to 1 over I. So we can actually replace this I with R over V, R being the resistance of the external load resistor, and V being the voltage that goes through this external load resistor. So let's write that down. Then, yeah, right here. So we'll put R here over V minus R. Okay, so now since we have that V here, we can actually use this. Okay, so we know that V, I forgot to write down this earlier, sorry. V is equal to 11.5. Okay, so now we can just input to find a lowercase r. And I believe, here I have my calculator with me. So we'll do this part first. So epsilon, that's 12.7. So 12.7 multiplied by r. Well, r is going to be 1. So it just stays the same. Divided by v. V is 11.5. And then we do minus r. And we know r is 1. And that we're left with, that is equal to 0.104 dot dot dot. So it's approximately, to 3 significant figures, 0.104. Thank you.